video number 3 of analysis of real-time radiography image of a weld. So we're starting about where we left off in video number 2, slightly different thing, and what we're going to do today with this one is we're going to determine the position in the weld of each indication. So if you remember in the first video, we figured out the low and the high, which are the positions. I'm calling it the x-axis because it's the first axis, even though it's vertical, of the weld edges. So we have those in those two subsets, low and high. And we're going to walk through and capture those on in our table. Okay, so this is the internal node of the label indications. We've got an internal data loop, and we're going to get to work. So we will do user-defined data. Okay, we pull that one out there. We drop that on there, and we do add C# compiler, and we click over here and we get the code. I'm not going to code live, but what I am going to do is I'm going to capture the code that I already wrote and paste it in, and then we can just look at that. So I've captured this code in here. I've gone compile. It spins for a bit on the first time and it's happy. You'd get an error up here if it's wrong. I'm just putting some typo there. So it says line 23, and you can tooltip over that if you want. You can also use Visual Studio if you want to do something more in depth, but the internal tools are sufficient in this case. So we're compiled. The next thing we need to do is we go back to the user-defined node, and you need to set the class that you're going to run, and there's only one, so it pretty much picks it for you. And we can hit compile here, and we get the outputs. And what these means are how far we are from the low edge, the high edge, from any edge, and from the center. And this is the code that I just dropped in. And basically it's done, this executable is done in 2 steps. The compile and the execute. The compile will allocate these 4 subsets. You can see the names here match. It gives them the usage, so they'll be captured by the label indications, and then it allocates the buffer. So the next thing we're going to do, node, this underscore node is this node here. So any of the tasks or properties that are running on node are acting on this. Okay, so this line here gets source is edges node. So what that means is I'm going to look for a source of this node, and it's going to be the edges node. And that one, you work by doing this. You drop our original data on here, makes a connection. That is source 1. So node source 0 is the edges node, and we're going to get out the first and the second, or the second and the third, because it's 0 base. So it's going to get out these 2 data subsets, and work with them. So we've captured these 2, which are the position at the weld edges, and then we need this x position. So what we're going to do here is we need some value that's an x position. So I'm going to say this extract indication, I want you to go up to my original weld, and then I'm going to do a repeat position 2D, and it wants to get everything happy and figure out why now this one is complaining, but we understand why it's complaining because it's saying, I don't know where the X of the indication is. So I've just grabbed the indication from above and dropped the X on. And remember from the last video, from low, that's the value it's going to capture. So I do this task again, developer tools, find internal data columns. Let's just I'll just check over here to see if we got them. Then we have all these values here. Okay, so maybe we should go over the C# again. So we've captured the two edges. We've captured the X position. That pulls the X position out of this value, and then we basically go through the data axes, get the position, the Y value for the indication, the Y value from the indication. We've looked at the axis here is what we're doing in this code. Then we pull out the high and low value and basically just do some math, subtract how far are you from the high edge, low edge. The edge is an absolute minimum of the absolute value. It's pretty straightforward math. But now we have a good idea in how far we are from the edges